Hello, I'm Professor Caudill, and once again, we're going to pick up where we left off. I think we're on 39, last part of 39, but I'm just going to go ahead and move to 40. So, average distance between Earth and the Sun is 10 to 11. Is the distance the Sun 10 to 11 meters. Calculate the average speed of its orbit. Okay. So, you want to know how many times the Earth goes around the Sun. So we want to know the velocity of this orbit given this distance. Alright, so meters per second. Alright. I am going to ask for help. I'm going to phone a friend. Help me get started answering. Use a formula for speed. Okay. Thank you. That's all I want. I don't care about the rest. I just need help. Okay, so speed is distance over time. So we want to know maybe I'm wrong, maybe 2 pi r. Radius is the average distance between the Earth and the Moon. Okay, so this is just extra. Don't worry about this. Determine the orbital period of the Earth. One full orbit around the Sun. 365 days. Okay. Is the circumference really necessary? Alright. I'm gonna assume we don't have to do the circumference. So we should have known that. So speed is 365 days. So this is roughly what is this? 10 to the 2.5. All right. And we want to convert days to hours. So there is 24 hours in a day. So we're going to say 10 It's the 1.5. So these cancel out. Ten to the 4 hours. We want to know how many hours. How many minutes are in an hour? Which is 60. 60 is close to 10 to the 2, so we're going to say 10 to the 2 minutes. I'm sorry. Hours. And I already know we're going to have to convert to seconds, so there's 10 to the 2 seconds in a minute. Alright, so this is going to okay, so these are going to cancel out. These are going to cancel out. So we're going to get 10 to the 11 meters per 10 to the 8 seconds, which is 10 to the 3 meters a second. Is it a good rough guess? The Earth rotates 3 meters 3 meters per second. So what is that? That's about 1,000 meters per second, maybe 2,000 miles an hour. 1,000 miles an hour. So we are close. I do wonder if we did 10 to the 1/2, get 60 minutes. One could say 3 is closer to 6 than 6 is closer to 10. So we could have gotten a better estimate if these minutes was instead 10 to the 1/2, 10 to the 1.5, and that would drop our order of magnitude to 2. No, that would increase it, I think. So that's 3. That'd be 7. So that'd be 10 to the 4. So I think that'd be worse. Okay. I'm trying to think how we could have gotten a better estimate. We're off by half an order of magnitude. So I would have just kept these 2s. Might be overthinking it. Or yeah. I'm just gonna move on. We're close. We're not horrible. It's kind of like a nitpicky thing. What is this in my speed in miles per hour? Okay, so what was that? 10 to the 3 meters a second. We want to convert this to miles. And we want to convert seconds to minutes, which is and 2 seconds. All right, so meter's gonna cancel out. We're gonna get 10 to the 3 meters over. I'm just gonna write this as 10 to the 3 seconds. So he's gonna cancel out. So we're left with, this should be mile. We're left with mile per 10 to the 4 hours. So this is 10 to the 0. So we are going to get 10 to the negative 4 miles an hour. Don't think that's right. What is the? I don't think this is close to right at all. What is this in miles per hour? So it should be 1,000 miles an hour. So what is this? We have 10. Right now we're at 10,000. Even if this was a positive, that would be 10,000. So yeah, we're way off. Okay, so we had 10 meters per second. And there's 1609 meters in a mile. Yes, that's correct. What's the rough order of magnitude going from? It should be 10 to the 4. Okay. So that would fix it, but it kind of says we're doing something wrong. So it's saying, okay, if we did, how many minutes are in a second? Let's say there's 10 to the 1.5 seconds in a minute. And 10 to 1.5 minutes in an hour. This, we're going to keep this 10 to the 3 meters. In the end, it'll be 10 to the 0 over 10 to the negative 10 to the 3 miles, which is okay. So these should be on top. These should be swapped. This should be, because we need seconds to cancel. So there's 10 to the 1.5 seconds in a minute. To 1.5 minutes in an hour. Okay, so if we do this, then seconds cancel out, minutes cancel out. We're left with 10 to the 3 miles an hour, which is around 1,000 miles an hour, and that's a little better. So from here on, 60 seconds, we're gonna estimate it as 10 to the 1.5. So I hope this is close. So we're kind of assuming 10 to the 1 half. It's about 3, and 10 to the 3 fourths, or 1.5 is approximately. I do want to get the actual number. $31. 10 to 0 is 3. So we can't do that. Well, 3/4 is not one. Okay, this is just wrong. 3/4, it's not 1.5. Okay, 75. This is about 6. All right. So we got the number we wanted, but we didn't get it the right way. So it should be 10 to the 3 meters a second times, converting this to miles, 1.6. 1.6 is closer to 3 than 0. So we'll say 10 to the half. Okay. And there is 10 to the 3/4 seconds in a minute, because 60 seconds in a minute, 60 seconds in a minute, 6 is about 10 to the 3/4 times 10 to 3/4 minutes in an hour. So adding all this up, we are going to get 10 to the 6/4, which is 10 to the 3/2. So 10 to the 3 times 10, 6/4, 3/2, 6/4, 3/2 over 10 to the 1/2. So that's going to be 3/2 minus 1/2 is 2/2, which is 1, which will be 10 to the 4th miles an hour. Which is way bigger than we want still. Okay, what are we doing wrong? Okay. 1.5 times 10 to 11. We could say that's 10 to 11. So that's 10 to 11. 10 to 11 meters per 365 days. Okay, which is 11.5 meters per 10 to the 2.5 days. Okay, so that is 10 to the 9, 10 to the 9 meters a day. Converting this to miles per hour. Miles per 10 to the 3.5. Okay, this should be 3.5, but too late now. Ten to the 3.5. Okay, times how many hours? How many hours are in a day? 24. A day over 10 to the 1.5, because 24 is close to 10. 2.4 is close to the square root of 10. So hours. Okay, so that should give us 10 to the 9 over 10 or 5, 10 to the 4 miles an hour. And that is still wrong, isn't it? Yep. Okay. 10 to 11 meters over 365 days. 365 days is 10 to 2.5. It's really, I don't know. I don't know if it comes down to the threshold. Like, are we saying 2.5? Is anything outside of this just rounded down to 10 to the 0? Let me review the book. I mean, this is like one of the first things they covered. .450 is 10 to the 3. So this is, you wouldn't expect that because you would think 4 is closer to half. But they're looking at the log of 450. But 250 is 10 to the 2. So it's not on the first two significant figures. Doesn't matter as much what the first two significant figures is. An equivalent but quicker way to find the order of magnitude is to first write it in scientific notation, where the first factor is greater than or equal to 3. First factor is less than 3. We round down to 1. Okay. First factor is greater than square root of 10. It's greater than square root of 10. We round up to 10. Example number 800 can be written in scientific notation as 10 to the 2. 8 times 10 to the 2, because 8 is bigger than 3, we say it's 10 to the 3. The number 4, so the order of magnitude is also 10 to the 3, okay? And it's less than 3. Okay. Okay, so let's try to do it again. 10 to 11 meters per 365 days, which is 10 to the, this is going to be 10 to the 3. 3 is bigger than the square root of 10. So this is going to be 10 to the 3. So it's going to be 10 to 11 divided by 10 to the 3, which is 10 to the 8 meters a day. Converting this to miles to 1609 meters, which is 10 to the 3. Okay. And then we want it in hours. So how many hours are in a day? It's 24. 2 is less than square root of 10. So 10 to 1. Okay, and this is going to give us 10 to the 4 meters, 10 to the 4 miles an hour. Is 10 to the 4 miles in RA. About 67,000 miles an hour. It's an underestimate, but if it is 67,000 miles an hour. It is approximately 10 to 6 bigger than 3, so it's 4 plus 5. 10 to the 5. And the 4, 2, 3, 4. It's about 10,000. Only thing I can think of is it might be this circumference. We know it's 365.25 days. Circumference of the Earth. The circle is 2 pi r. So it's saying r is 10 to 11. Okay. So we still have 2 times pi, which is about 6. So if we could get this extra order of magnitude by saying 6 is about 10 to the 1, which would change this c to 10 to the 12, and then this would get 10 to the 5. And that'd be so like 100k is closer to 67k than 10k. So why we're struggling is we didn't think about the circumference of a circle. It's 2 pi r. We were naive and just said this was r. It's not r. So I'm gonna say that's a hard problem, but you see how with ChatGPT or any large language model, we were able to get a better estimate, able to build better intuition for future problems. So that's like 33 minutes for one problem, but who knows, it might be worth it. Density of nuclear matter is 10 to 18 kilograms per meter. Okay, so density is okay. Given what is the density in megagrams per microliter? Okay, so we have 10 to the 18 times 10 to the 3 grams meters cubed. We're going to say that's 10 to the 21. And we want to convert this to megagrams. So There's 10 to the 10 to the 6 megagrams in a gram, or 1 gram is equal to 10 to the 6. Is that right? Has to be right, I think. 1 kilogram is 10 to 3, 10 to the 6. Okay. So this is equal to 10 to the 15 times 10 to the 6 grams is 10 to the 15 megagrams, megagrams. Okay, and we want the answer. We want the answer in microliters. Okay. Microliters. We want it in microliters. Okay. So first we need to convert this to that. So converting meters to centimeters. I have to cube this. So 10 to the negative 6. So and then I get 3 centimeters. Is that right? I don't think that's right. I think it's just... Okay, so it's negative 6 plus negative this. Oh. Alright. Man. Meters. Converting meters to centimeters. That would be... I have to cube this. So 2 times 2 is 4. No, when you multiply, so 10 to the negative 2 to the power of 3 is negative 6. Okay. which is 10 to the 9 milligrams per centimeter. Converting this to, like, I'm about 10% confident here, but we're gonna chug through it. Maybe we get lucky. So we're gonna convert this into milliliters. So this is just, we can just equate this 10 to the 9 milligrams per milliliter. Now we need to convert milliliter to micrometer. So there's micro is 10 to 6. So should be 10 to the 3. So that should be 10 to the 3 micrometers. So I think the final answer is 10 to the 6 megagrams per microliter. Probably wrong. So we're off by a lot. So starting over, 10 to 18 kilograms given we want to find the density. We want to know this in milligrams per okay. How does the language model do it? Density in milligrams per kilogram. Convert kilograms per meter to milligrams per centimeter. Okay, so to megagrams. So it's saying 10, 18 kilograms. Multiply So how many megagrams are in a kilogram? It's saying 10 to the 6. That makes intuitive sense to me. Um, it's hard to think about, like, does can you tell from this graph that there's 10 to the 6 kilograms in a megagram? I could try to argue 10 to the 6 minus 10 to the 3. There's 10 to the 3 kilograms in a megagram. So that's where my intuition is failing. Okay, so that will be, so these will cross out. Then that's 10 to the 12 megagrams per meters cubed. So same logic without following the computer. Meters, centimeters. So how many meters, how many centimeters is in a meter? So there's centi, 10 to the negative 2 in a meter. So meter is the base. Either way, it should be 10 to the negative 2. Okay, which is 10 to the 6. So I'll leave us with 10 to the 6 megagrams per, which is 10 to the 6 megagrams per milliliter. How many milliliters are in a micrometer? So we went from, so going from kilo to mega is 10 to 6. Going from milli to micro should also be 10 to the 6. Okay, and then those should just cancel out, and it should just be 1 megagram per microliter. And we're not getting 10 to the 12. Okay, the solution has to be, this needs to be up here, but not there. That's what I would guess. So what would this be saying? There's 10 to the 6 milliliters in a microliter. All right. Let's move on. Try to get one more before we're done for the day. So density of aluminum, 2.7 grams cubic centimeters. What is the density in kilograms? We want to know this. And okay. So let's say this is 2.7 kilograms. So that's just 2.7 grams times 10 to the 3 grams. So that's or yeah, that's probably right. I was thinking if I could have done like an estimate, like just cancel out this, just wrote 10 to the 3 kilograms per centimeter. I don't think it's necessary to do that though. So 43 pound mass. Pound mass. Okay. What is the density of water and pound mass per cubic foot? Alright, so it's not making sense to me yet. Um, Pound mass per cubic foot. I don't know why we need to know this. Maybe we already have density of water. I think density of water. Okay, we know density of water earlier is 10 to 3 kilograms per meters cubed. Okay, so we want to convert kilograms. So we want kilograms on bottom. So it's going to be pound mass. And that's just 10 to the 0 divided by so 0.454 is 4 times 10 to the 1. It's closer to 10 to the 0 or 10 to the negative 1, I would say. Man. So 1/2. This is about 1/2. So 1/2 is, it's less than 1/2. So 1/2 is closer to 0.1. So this is closer to 0.1. So this is 10 to the negative 1. So these will cancel out. This will be 10 to the 2 pound mass per meters cubed. Okay, now we need to convert meters cubed to foot cubed. I think there's 9 meters, or let's say 1609 is 10 to the 3 meters in a foot. We have to cube this. So that's 9. So that should be 10 to the 9 pound mass per foot cubed. Is 10 to the 9 10 to the 9, 10 to the 9, 10 to the 9. Let's see if we got it right. $62. It should be 10 to the, should be 10 to the 2. Off by 7 orders of magnitude. Great. Okay. Alright, we'll end it there. Next time we'll return to number 43. So thank you guys. I'll see you next time.